This is the EdExcel GCSE 9-1 Maths Higher Paper 1, which is a non-calculator paper, and it's from the June 2018 series. Question number 1 for part A. We have to work out 2 1/7 plus 1 1/4. Well, what we have to do to begin with is convert these mixed numbers into improper fractions. And so, if we begin with the 2 1/7, well, we have the 2 multiplied by the 7 plus the 1, and this is being divided by the 7, and then we add on to this 1 1/4, and this as an improper fraction. We have the 1 multiplied by the 4 plus the 1 divided by 4. And so if we work this out, well, 14 plus 1, that's 15. So I've got 15 over 7 plus, and here we have 5 over 4. We need to add, therefore, 15 over 7 to 5 over 4. And to do this, we can combine the fractions by rewriting them over a common denominator. And so if we were to do that, the common denominator of 7 and 4, that would be 28. And so we multiply the 15 by 4 to get 60. And we multiply the 5 by 7 to get 35. And so we have 60 plus 35 divided by 28. And so if we were to simplify all of this, we have 95 over 28. And so the result of this sum is 95 over 28. And then for part B, we have to work out 1 1/5 divided by 3/4. First of all, let us convert the mixed number 1 1/5 into an improper fraction. To do that, we have the 1 multiplied by the 5 plus the 1 divided by 5, and then we divide this by 3/4. And so if we were to simplify this even further, five plus 1, that's 6, and we are dividing this by 5. And then we have the 3/4. Now, when we divide fractions, we multiply the first fraction by the reciprocal of the second fraction. And so what that means, we have 6/5 multiplied by 4/3. Now we can see that the 3 cancels with the 6 twice. And so what we have then is 2/5 multiplied by 4, which is 8/5. And if we were to write 8/5 as a mixed number, we are questioning how many times does 5 go into 8? Well, 5 goes into 8 one whole time, and what's left over is 3/5. And so we end up with 1 3/5. Question number 2. In a village, the number of houses and the number of flats are in the ratio 7:4. The number of flats and the number of bungalows are in the ratio 8:5. There are 50 bungalows in the village. We have to find out how many houses are there in the village. To do this question, we need to find the ratio houses to flats to bungalows. So we have houses to flats to bungalows, and we need to find out what this ratio is. Now, we know that the ratio of houses to flats is 7:4. The ratio of flats to bungalows is 8:5. Now, to find the ratio house to flats to bungalows, we need to make the flats the same, and that's because it's common to both houses to flats and flats to bungalows. And so if we were to get the flats the same, well, since 4 is a factor of 8, what we ideally want is an 8 here. And so from the 4 to the 8 we multiply by 2, and so I have to multiply the 7 by 2 to get 14, and to go from the 8 to the 8, well, of course I multiply by 1, and that gets me 5. So the ratio houses to flats to bungalows is 14 to 8 to 5. And what we are told in this question is there are 50 bungalows in the village. So for bungalows, we have 50 of them. How do I go from the 5 to the 50? Well, I simply multiply by 10, and so if I multiply 8 by 10, I get 80, and if I multiply 14 by 10, I get 140. And so the ratio houses to flats to bungalows, we have 140 to 80 to 50. How many houses are there in the village? That will be 140. Question number 3. Rennie buys 5 kilograms of sweets to sell. She pays £10 for the sweets. Rennie puts all the sweets into bags. She puts 250 grams of sweets into each bag. She sells each bag of sweets for 65 pence. Rennie sells all the bags of sweets. We have to work out her percentage profit. Well, first of all, you'll notice we've got grams here, kilograms here, pence here, and pounds here. And so we would have to make the units the same. To go from kilograms to grams, we multiply by 1000. and grams to kilograms we divide by 1000. From pounds to pence we multiply by 100. From pence to pounds we divide by 100. And so if we have 5 kilograms of sweets to sell, multiplying the 5 by 1000, it turns out we get 5000 grams of sweets to sell. And if we sell each 250 grams of sweets in the bag for 60 pence, well, if I convert that into pounds by dividing it by 100, we have 0.65. So, what do we know already? We know that for 5000 grams, this costs us £10. Now, we are putting 250 grams into one bag, so we can find out the cost of one bag. One bag contains 250 grams, and so dividing by 20, it turns out one bag would cost £10 divided by 20, which is 50p. So, each bag would cost 50p or £0.5. And if we sell each bag for 65p or £0.65, what we can do is find the profit per bag. So the profit per bag, we have 65 pence, subtract 50 pence, it turns out the profit per bag is 15 pence. And knowing what the profit per bag is, we can now find out the percentage profit. So the percentage profit, we have 0.15 divided by 0.5, and then we times this by 100. 15 over 50, 3/10 multiplied by 100. And so what we end up with is 30%. So we have 30%. Question number 4. A cycle race across America is 3,069.25 miles in length. Juan knows his average speed for his previous races is 15.12 miles per hour. For the next race across America, he will cycle for 8 hours per day, and for part A, we have to estimate how many days Juan will take to complete the race. Well, because in this question the keyword is estimate, what we have to do is round these values to sensible values. And so the 3,069.25 miles, a sensible value for that is 3,000. A sensible value which we can round the 15.12 miles per hour to is 15 miles per hour. What we need to do is find out the number of days Juan will take to complete the race as an estimate. And so what we can do is recognize that we have an average speed for the previous races. We have a time for the next race, and with this we can find the distance per day. And if we find the distance per day, we have 15 miles per hour multiplied by 8 hours. And it turns out the distance per day then is 120 miles. And what we can now do is find out the number of days it will take to complete the race. So the number of days it will take, well, if we do 120 miles per day, and if in total the cycle race is 3,000, we can do 3,000 divided by 120, which tells us an approximation for the number of days is 25. So we have 25. And then Juan trains for the race. The average speed he can cycle at increases. It is now 16.27 miles per hour. We have to think about how this will affect our answer to part A. Well, in this case, the race will be completed in a shorter time. Question number 5. Here is a solid square base pyramid VABCD. We've got the front view here. The base of the pyramid is a square of side 6 centimeters. The height of the pyramid is 4 centimeters. M is the midpoint of BC and VM, equals 5 centimeters. For part A, we have to draw an accurate front elevation of the pyramid from the direction of the arrow. Well, we are looking at the shape from the front view, and what we will see is a triangle with the base of 6 and the height of 4. So let's draw that. We have our triangle with a base of 6, and we have a height of 4. So now let's add on the measurements. We have 6 centimeters for the base, and for the height we have 4 centimeters. And now we have to work out the total surface area of the pyramid. Well, if I look at my viewpoint, I've got one of these triangles which I can work out the area for, but I've got 4 of them. We have 4 congruent triangles with base 6 centimeters and height 4 centimeters. And what we also have is the area of the square. And so the total surface area, well, to work out the area of one triangle, we have 1/2 times by the base, which is 6, times by the height of 5. And we have 4 of them. And then we have the square, which has an area of 6 by 6. And so if we work this out, 2 times 6 times 5 is 60, plus the 36. We have 96 centimeters squared. So we have 96 centimeters squared. Question number 6. A pattern is made from 4 identical squares. The sides of the squares are parallel to the axis, as we see here. Point A has coordinates 6, 7. Point B has coordinates 38, 36. The point C is marked on the diagram. We have to work out the coordinates of C. Well, if I think about how we go from the 6 to the 38, well, we add 32 to 6 to get 38. And so we can see from A to B in the x direction is 32. Now to go from 7 to the 36, we add 29 to 7 to get 36. And so to go from A to B in the y direction, we add 29. Now we can find out the length of each side of the square. We can do this by recognizing that the 4 squares in the x direction would make up the 32. And so for each side of the square, 32 divided by 4, that's 8. So each side of the square is worth 8. Notice 4 times 8 gives the 32. And so, because we have a square, each side has the same length of 8. So we have 8s, as we see here. And for us to find the coordinates of C, well, this length, to find out what that is, we have a total length of 29, and this 8, this 8, and this 8, plus this length here will give 29. And so that length will equal 29 subtract the 8 subtract the 8 here, subtract the 8 here. And so what this is equal to is 5. So this length here is 5. And if that's the case, well, that means because each side of a square adds up to 8, this side over here must be 3. And so therefore, this length here will be 5. Because the 3 and the 5 give 8. And so we are now in a position to find out the x coordinate of C and the y coordinate of C. For the x coordinate, well, let's consider what's going on in the x direction. We start off at 6, which is the x coordinate of A, and then we add on 8, and then we add on the 8 here, and that gets us 22. So we have the x-coordinate of C being 22, and for the y direction, we start off at 7, we add on the 8, and then we add on the 5. And so what we end up with over here is 20. The y coordinate of C is 20. Question number 7. Shape T is reflected in the line x equals -1 to give shape R, and then shape R is reflected in the line y equals -2 to give shape S. We have to describe the single transformation that will map shape T to shape S. Well, let's begin by reflecting in the line x equals -1. Here we have the line x equals -1, and if we reflect shape T to give shape R, then here we would have the shape R, and then shape R is reflected in the line y equals -2. So here is the line y equals -2, and if I reflect shape R in the line y equals -2, that means we end up with this shape over here. We'll call it shape S. And what we need to do is describe the single transformation that will map shape T to shape S. Well, if we match up the vertices, this one with this one, say, then this one with this one, and then this one with, rather, this one with this one, and this one with this one, it turns out what we have over here is a rotation 180 degrees clockwise with center -1, -2. Question number 8. The perimeter of a right-angled triangle is 72 centimeters. The lengths of its sides are in the ratio 3:45. We have to work out the area of the triangle. Well, we can approach this question by using a bar model. So here is our bar model representing the ratio 3:4:5. We know in total we have the sides adding up to 72. We were told that in the question. And so therefore, to find out what each part is worth, well, altogether we have 12 parts. The 3 plus the 4 plus the 5 is 12. And if we do 72 divided by 12, that's 6. So each part is worth 6, as we see shown here. And so the total for here is 18. The total for here is 24, and the total for here is 30. Now we are told we have a right-angled triangle, so we have a 3-4-5 triangle. Its lengths have been scaled up to 18, 24, and 30, And so what we can see here then is to work out the area, we have 1/2 times by the base, which is 18, times by the height, 24. It turns out the area is 216 centimeters squared. Question number 9. For part A, we have to write down the value of 36 to the power of 1/2. Well, that will be the positive square root of 36, which is 6. For part B, we have to write down the value of 23 raised to the power of 0. Well, anything raised to the power of 0 is 1. For part C, we have to work out the value of 27 raised to the power of minus 2/3. Well, if we have 27 being raised to the power of negative 2/3, what this is the same as is 1 over 27 to the power of 2/3. And so if we work this out, we have 1 over and then 27 to the 2/3. That's the same as raising 27 to the 1/3 and then squaring the result. And 27 raised to 1/3, that's the same as the cube root of 27, which is 3, and then we square this. And it turns out our answer is 1/9. So we have 1/9. Question number 10. The table gives some information about the heights of 80 girls. We've got the least height, the greatest height, the lower quartile, the upper quartile, and the median. For part A, we have to draw a box plot to represent this information. Well, we've got 133 for the least height. So if we plot that, that is over here. We've got the greatest height at 170. That's over here. We've got the lower quartile at 145. That's here. The median at 151. And the upper quartile at 157. Now we simply join these up like so, and then we join these up. Here is the completed box plot. And then for part B, we have to work out an estimate for the number of these girls with a height between 133 and 157. Well, we know that the 133 centimeters would correspond to the minimum, that's given here, and the 157 would correspond to the upper quartile. So when we come to work out the estimate for the number of these girls with a height between 133 and 157, hopefully you can see that would be 3/4 of the data. And so 3/4 of, well, what we know is there's 80 girls, so we need to work out 3/4 of 80, and it turns out that's 60. 3/4 of the data, well, we have 3/4 of 80, which is 60. Question number 11. A and B are points on a circle with center O. BC is a tangent to the circle and AOC is a straight line, and the angle ABO is the angle X. So the angle ABO, if I draw a line connecting O and B, the angle here is X. And what we need to do is find the size of the angle ACB in terms of X in its simplest form. So we need to work out what this angle here is. Well, if we know that the angle ABO is X, that means the angle well, first of all, the length AO and BO, so that's AO and BO, those are equal. Those are equal because they are both radii. We are going from the center to the circumference, that's a radius. And so what we can conclude from here then, the triangle AOB is isosceles. And because of that, and because we also know that the base angles of an isosceles triangle is X, that means the angle OAB, which is equal to the angle ABO, is also X, and the reason for that is base angles in an isosceles are equal. And what we can also do is find out what this angle here is, the angle OBC. The angle OBC is equal to 90 degrees, and the reason for that is the tangent meets the radius at right angles. OB is a radius, BC is a tangent, they meet at right angles, so the angle here is 90 degrees. And so what can we conclude from this? The angle ABC then that will equal the 90 degrees plus the X. And so because we know this angle, we know what this angle is, we can find out what this angle is, recognizing that the sum of the angles in a triangle add up to 180. So the angle ACB, that's equal to 180 subtract the X from here subtract the X plus 90, which is what we just found here, and it turns out we get 90 minus 2x. So the angle here is 90 minus 2x. The reason for this, angles in a triangle sum to 180. Question number 12. We have to prove that the square of an odd number is always one more than a multiple of 4. First of all, let's start off by saying that if n is an integer, then 2n plus 1 will be odd. We multiply an integer by 2, we get an even number. Adding 1, that makes a number odd. And so that means that 2n plus 1 all squared a square of an odd number, which is why we square like so. Well, that's equivalent to 2n plus 1 times 2n plus 1. 2n times by 2n is 4n squared, then we have 2n times 1 twice, so that's 2n, and then we have the 1 here. Rather, here we have the 4n plus the 1. And if we factorise out a 4, we have 4 times by n squared plus n, and then we can add on the 1. What we see here is by multiplying by 4, well, we've also got the 1 more here. What we can say then is the statement is true. So therefore the square of an odd number is always 1 more than a multiple of 4. Question number 13, we have root 5 times by root 8 plus root 18 can be written in the form a times root 10, where a is an integer. We have to find the value of a. Well, we can multiply the root 5 by the root 8. So we have root 5 times by root 8. And then we also have the root 5 times by the root 18. And if we add these together, well, root 5 times by root 8, that is the same as 40 square rooted. And then we add on to this root 5 times root 18, which is the same as the square root of 90. 5 times 18 is 90, and we square root that. Now, the root 40 we can rewrite as root 4 times by root 10. And the root 90 we can rewrite as root 9 times by root 10. So root 4 times root 10, that's the same as 2 root 10. And then root 9 times root 10, that is the same as 3 root 10. Altogether, we have 5 root 10. A is therefore equal to 5. Question number 14. Y is inversely proportional to d squared when d is 10, y is 4. D is directly proportional to x squared when x is 2, d is 24, and we have to find a formula for y in terms of x. Give your answer in its simplest form. Well, we have d, rather we have y, which is proportional to 1 over d squared. In other words, it's inversely proportional to d squared. And from this we can conclude that a is equal to, rather that y is equal to some constant a over d squared. And we can find out the value of a by using the condition d equals 10, y equals 4. 4 equals a divided by 10 squared, and so therefore a is equal to 4 times 100, which is 400. And knowing that, we can see then y is equal to 400 divided by d squared. Now, we also know that d is directly proportional to x squared, so I have d in direct proportion with x squared. In other words, d equals some constant b times x squared. And we have the condition x equals 2, d equals 24. So I have 24 equals b multiplied by 2 squared. In other words, b is equal to 6. And so therefore we can conclude from here then, d equals 6 times by x squared. Now we need to find a formula for y in terms of x. We don't want any d's. So if I call this equation 1 and this equation 2, we can substitute in equation 2 into equation 1. And so if we do this, we have y equals 400 divided by d squared, so that is 6x squared squared. So we have 400 over 36 x to the power of 4. And what this will simplify to, 400 divided by 36, that's 100. We have 100 divided by x to the 4. Rather, 100 divided by 9x to the 4. And so this is what our formula is. Y equals 100 over 9x to the 4. Question number 15 for part A. We have to factorise a squared subtract b squared. Well, we should spot we have a difference of two squares. So we have a plus b multiplied by a minus b. Then for part B, hence or otherwise, we have to simplify fully x squared plus 4 all squared, subtract x squared minus 2 all squared. Well, if we compare with a, then what we can see is the value of a is x squared plus 4. So the x squared plus 4 is what we have over here, and the b is x squared minus 2. And so with that, we can use the difference of two squares to find out what the expression simplifies to. So therefore, x squared plus 4 squared subtract x squared minus 2 squared. Well, this will be equivalent to, well, I have a plus b, so that is x squared plus 4 plus x squared minus 2. And then I'm multiplying that by a minus b. So that's x squared plus 4 minus x squared minus 2. And so what we end up with then, we have x squared plus x squared, that's 2x squared, and then 4 minus 2, that's 2. X squared plus 4 subtract x squared minus 2, well, I've got x squared minus x squared, that's 0, and then I've got 4 subtract negative 2, which is 6. And so if I expand this out, we have 12x squared plus 12, and we can factorise out the 12, leaving us with 12 times by x squared plus 1. So we have 12 times by x squared plus 1. Question number 16. There are only red counters, blue counters and purple counters in a bag. The ratio of the number of red counters to the number of blue counters is 3 to 17. Sam takes at random a counter from the bag. The probability that the counter is purple is 0.2. We have to work out the probability that Sam takes a red counter. Well, first of all, 0.2, that is the same as 1/5. And so if we take a look at red to blue to purple, the ratio of red to blue, that's 3 to 17. And then to purple, well, we don't know what purple is, but we'll call it X for now. We know the probability of selecting a purple is 1/5. So the probability of purple is equal to, well, how do I work out the probability of a purple? Well, I've got 3 plus 17 plus X in total, and of those, X is purple. And I know that this will equal 1/5. So from that, I can find out a simplified equation. For our simplified equation, we would have X over 20 plus X, and that's equal to 1/5. So we can now find out what purple is. In other words, we can find out what X is. And if we cross multiply, we have 5 multiplied by X equals 1 multiplied by 20 plus X. So 5X equals 20 plus X. 4X is 20, which means X is equal to 5. So now that we know what X is, we can therefore find the ratio red to black to purple. So we have the red counters to blue to purple, that's equal to 3 to 17 to 5. And so the total that's equal to 3 plus 17 plus 5, which is 25. And therefore the probability of red, that's equal to 3/25, because we have 3 out of 25. Question number 17, we have to simplify fully. 3x squared minus 8x minus 3 over 2x squared minus 6x. Well, we have 3x squared minus 8x minus 3, which we need to factorize. We require two numbers which multiply to give 3 times minus 3, which is minus 9, which add to give minus 8. Those two numbers, we have minus 9 and 1. So we can rewrite this as 3x squared minus 9x plus x minus 3. So we have 3x times by x minus 3 plus 1 times by x minus 3, leaving us with 3x plus 1 multiplied by x minus 3. And the 2x squared minus 6x, we can factorize out the 2x, and inside the bracket we would have x minus 3. And so we can therefore simplify the required result. we have 3x squared minus 8x minus 3 divided by 2x squared minus 6x. What is this equivalent to? Well, this will be equivalent to 3x plus 1 multiplied by x minus 3 divided by 2x times by x minus 3. Now the x minus 3's simplify to 1 on the top and bottom, so we have 3x plus 1 divided by 2x as our simplified result. Question number 18. Here is the graph of y equals sine x degrees for x being in between minus 180 and 180, and we have to draw the graph of y equals sine x minus 2 between minus 180 and 180. Well, here we have the graph of y equals sine x, and what I'm doing in this question to go from y equals sine x to y equals sine x minus 2 is I am translating, so my transformation is a translation by vector 0 minus 2. And so if here is our original graph, we are moving this 1, 2 units down. What we end up with here is y equals sine x minus 2. Question number 19. The point P has coordinates 3, 4. The point Q has coordinates A, B. A line perpendicular to PQ is given by the equation 3x plus 2y equals 7, and what we have to do is find an expression for B in terms of A. Well, in general, an equation of the straight line is given in the form y equals mx plus c. And m here would represent the gradient, and c would represent the y-intercept. And so if we have our line 3x plus 2y equals 7, we can rearrange this in the form y equals mx plus c. And if we rearrange this in the form y equals mx plus c, well, first of all, 2y is equal to negative 3x plus 7. And therefore y is equal to minus 3 over 2 x plus 7 over 2. So what can we conclude from this? Well, we can conclude that the gradient is equal to minus 3 over 2. And what we want is the perpendicular gradient. The perpendicular gradient of PQ, that's equal to the negative reciprocal of negative 3 over 2. And it turns out here we get 2/3. And so the gradient of our new equation is 2/3. Now we know that our line passes through the point P, and it passes through the point Q. So if I consider the point P with coordinates 3, 4, using y equals mx plus c, I've got y, which is 4, equals m, which is 2/3, times by 3, which is the x coordinate, plus c. 4 equals 2 plus c. C is equal to 2. And what we can therefore conclude is PQ would therefore have equation y equals 2/3 x plus 2. And if we now consider the point Q with coordinates A, B, y is B, x is A, so I have B equals 2/3 A plus 2. So this is my equation. We have B equals 2A over 3 plus 2. Question number 20. N is an integer such that 3n plus 2 is less than or equal to 14 and 6n over n squared plus 5 is greater than 1. We have to find all the possible values of n. Well, let's take a look at this inequality. 3n plus 2 is less than or equal to 14. We can subtract 2 from both sides, leaving us with 3n is less than or equal to 12. And dividing both sides by 2, we end up with n is less than or equal to 4. Let's now take a look at 6n divided by n squared plus 5 being greater than 1. We have 6n being greater than 1 multiplied by n squared plus 5. We have 6n being greater than n squared plus 5. N squared subtract 6n plus 5 is less than 0. 0 is less than n minus 5 times n minus 1. And if I draw a quick sketch to help solve this inequality, well, if I just draw the axis out over here, here is my inequality. I've got solutions at 1 and 5, and I want the solution where it's less than 0, which is in between 1 and 5. So n is in between 1 and 5. But we know from the question that n is less than or equal to 4. It's less than or equal to 4, and it's also in between 1 and 5. So therefore the possible values of n we could have 2, 3 and 4 as our solutions. N's also an integer, which is why we only choose whole numbers.